In this Leetcode, we have very simply to take a string which contains Roman symbols and convert this Roman number into an actual integer. We have to pay attention, of course, to all the rules related to Roman numerals. Like, for example, this symbol can be placed before the V and X. And basically, this means that this symbol is subtracting 1 to the actual value 5. So these are the kind of inputs I can get, and I have to convert to the actual number 3. These are the constraints. I'm sure that the string contains only these symbols, so I don't have any kind of exceptions. The string length is maximum 15, minimum 1, so I don't have a null string. And we are guaranteed that the string is actually a real numeral in this specific range. So it shouldn't be too difficult. So here I have my simple main test with this symbol. So we have this string as an input to our function. Every symbol has a specific value, and the loop is gonna be simple. I'm gonna iterate over every symbol, and I'm gonna stock the relative value into a counter, right? So we'll have a counter plus equal m. Then I'm gonna go to this symbol, I'm gonna add the relative value. Then again m, then again x, and so forth, right? At the very end, I'm gonna return the actual counter. Now, I have to pay attention to these rules. So depending on the actual position of these three symbols, the semantic meaning of this symbol changes. For example, if this I is placed before this V, this I means -1 and not +1, and so forth. So the implementation is gonna be pretty simple. I'm gonna do some logic. Depending on the context, this symbol will have a specific value. So let's declare our actual counter that I call result, and immediately I initialize to 0. Then I'm going to do while at s, right? It's different from \0, but this is redundant, so I can simply write like that. So until this condition is true, at the very bottom I'm going to increase the actual pointer. What do? Well, you do a switch at s. Okay, so I'm gonna every time fetch the actual char pointed. So for the first iteration, the char pointed is gonna be this m, right? And here I'm gonna do all my cases. So case I, right? What do? Here, of course, the curly brace like that. So case I, this can mean +1 or it can mean -1 if it is placed before this v or this x. So I think a ternary operator here is pretty neat, I have to say. Result plus equal, and then the following char, namely this char here for the first iteration, right? So char +1. Here I write s square bracket, I will use the square bracket 1. This simply means the following char because it's like writing at s +1. It's the same thing, but with the square brackets we have syntactic sugar that makes the code more readable. Equal to v, right? Or same code, but this time x question mark. If this is the case, result -1, right? On the contrary, +1, like that, right? And then we simply have to break. You can understand the logic here, right? Here I make the question, hey, is the following char in the first iteration is gonna be this c equal to v or equal to it? If this is the case, well, just subtract 1 to the result. On the contrary, you add 1. Easy, right? So we apply this logic for all these cases. So I'm gonna copy this because it's gonna be self-similar. So copy everything. Okay, like that. And we simply change the value. So here I'm gonna put x, here I'm gonna put c. So if the following char here is L or C, here -10 or +10. Last case we have D or M, right? -100 plus 100. Perfect. So now we have written in code basically all these cases. Now we're gonna have all these symbols. So now we're gonna do all the other cases. So we still have to do case V. What is case V? Well, it's simply result plus equal 5 and break. Then we have case L, result plus equal 50 break. Case D, result plus equal 500 break. Okay. Case m, the last one, is gonna be result plus equal 1000. Break. We're done. At the very bottom, we simply return result. Okay, I think the algorithm is already made. Okay, compile, launch. Something wrong, like always. What's up? Oh yeah, of course, I have my ++s inside here, but this is wrong. Okay, let's compile again. Launch. All right, the integer representation is perfect. Okay, now let's just check in Leetcode. Okay, the solution is faster than 86 something, and memory-wise is not very good. So it can be improved a lot, but I'm pretty happy with this function.